Hello friends, in this video we will discuss about methods of preparation of alkanes. First method, from unsaturated hydrocarbons, dihydrogen gas, that is H2, adds to alkenes and alkynes in the presence of finely divided catalysts like platinum, palladium or nickel to form alkanes. See the reaction? This is ethene, CH2 double bond CH2. When added with H2 in the presence of Pt or Pd or Ni, it will convert into ethane. Propene, CH3CH double bond CH2 plus H2 catalyst propane. Propyne, CH3C triple bond CH, two molecules of hydrogen added and this will convert into propane. In all these reactions, hydrogen is added. That's why this process is called hydrogenation. And this hydrogen is added in the presence of catalyst. That's why this is also known as catalytic hydrogenation. Okay. Pt and Pd catalyze the reaction at room temperature. But relatively higher temperature and pressure are required with nickel catalyst. From alkyl halides, we have two methods to prepare alkanes from alkyl halides. First one is alkyl halides except fluorides on reduction with zinc and dilute hydrochloric acid give alkanes. Actually, in this reaction, first of all zinc and dilute hydrochloric acid reacts, and in this reaction hydrogen gas is liberated. That hydrogen gas reduces the alkyl halide. For example, this is chloromethane on reduction will convert into methane. Chloroethane on reduction with zinc and HCl, this will convert into ethane. 1-chloropropane on reduction, this will convert into propane. Second method, from alkyl halides to get the alkanes. Alkyl halides on treatment with sodium metal in dry ethyl, that is dry ether. Dry ether means the ether which is free from moisture. So, in dry ethereal solution give higher alkanes, and this reaction is known as Wurtz reaction. And this is used for the preparation of higher alkanes containing even number of carbon atoms. For example, bromomethane. This is the one molecule of bromomethane. This is another molecule of bromomethane. These two molecules react with the sodium in the presence of dry ether. Then this NaBr is removed and we will get ethane. Now just see number of carbon atoms. In each molecule of bromomethane there is one carbon atom. Okay, but in the product there are two carbon atoms. So number of carbon atoms increases. Higher alkanes are obtained. Same way, bromoethane. This is one molecule of bromoethane, C2H5Br. This is another molecule of bromoethane, C2H5Br. Reacts with sodium in the presence of dry ether, and again 2 units of NaBr are removed, and this will convert into normal butane, C2H5, C2H5, or we can say C4H10. Okay. Once again, you can check the number of carbon atoms. In each molecule of bromomethane, 2 carbon atoms are there, but in the product, 4 carbon atoms are there. Okay. Now, question is there, what will happen if two different alkyl halides are taken? Our answer is mixture of alkanes will be obtained. Now, just check it. If we take one molecule of CH3Br and another molecule of C2H5Br, okay, in the presence of, it will react with the sodium in the presence of dry ether. This is dry ether. Now, what products we will get? Now, there are three possibilities. Two molecules of CH3Br will react and this will convert into C2H6. Ethane is formed. Two molecule of C2H5Br react and this will convert into C4H10, that we will get the normal butane. Now, when one molecule of CH3Br and one molecule of C2H5Br react, then we will get the C3H8. So, we will get the mixture of alkanes. Again, this method is not suitable to get the alkanes having odd number of carbon atoms. Okay? जैसे यदि आपको odd number of carbon atom में C3H8 बनाना है, प्रोपेन बनाना है, तो प्रोपेन बनाने के लिए आपको एक मोलिक्यूल ब्रोमोमीथेन का लेना पड़ेगा, एक मोलिक्यूल आपको ब्रोमो इथेन का लेना पड़ेगा. तो यहाँ पर हमें ये दो और मिलेंगे. That's why this is not suitable. We will get the mixture of alkanes from carboxylic acids. Again, we are having the two methods to get the alkanes from carboxylic acids. Sodium salts of carboxylic acids on heating with soda lime. Actually, soda lime is a mixture of sodium hydroxide and calcium oxide. Give alkanes containing one carbon atom less than the carboxylic acid. And in this, carbon dioxide gas is removed. So, this process of elimination of carbon dioxide from a carboxylic acid is known as decarboxylation. Take one example. This is the sodium salt of ethanoic acid and this is known as sodium ethanoate. In common names, this is known as sodium acetate. When this reacts with the soda lime, that is NaOH and CaO, when this is heated, we will get the methane. Now just compare the number of carbon atoms. प्रोडक्ट के अंदर एक कार्बन एटम है और रिएक्टेंट में आपने जो सोडियम साल्ट लिया कार्बोक्सिलिक एसिड का, इसके अंदर दो कार्बन एटम आ रहे हैं. ओके, तो जो प्रोडक्ट बन रहा है उसके अंदर एक कार्बन एटम लेस है. प्रॉब्लम 13.6. सोडियम साल्ट ऑफ विच एसिड will be needed for preparation of propane. Write chemical equations for the reaction. We discussed कि जो एल्केन बनता है उसके अंदर एक कार्बन एटम कम हो जाता है. यानी कि यदि आपको प्रोपेन बनाना है तो जो भी आप इसके लिए कार्बोक्सिलिक एसिड लेंगे उसके अंदर एक कार्बन एटम ज्यादा होना चाहिए. यानी कि ब्यूटेन से कार्बोक्सिलिक एसिड जो बनेगा ब्यूटेनोइक एसिड, और उसका सोडियम साल्ट लेंगे तो सोडियम ब्यूटेनोइट. तो आपका आंसर हो जाएगा sodium salt of which acid? Answer is sodium salt of butanoic acid. Okay, this is the reaction. This is sodium butanoate. React with the soda lime. This will give propane. Okay. From carboxylic acid, there is another method, Kolbe's electrolytic method. An aqueous solution of sodium or potassium salt of a carboxylic acid on electrolysis gives alkane containing even number of carbon atoms at the anode. Okay, alkane is liberated at anode. This is the overall reaction. This is sodium acetate, water, electricity is passed, that is electrolysis. Electrolysis means, lysis means breakdown. Electro means electricity. Breakdown by using electricity, you will get the CH3 plus CO2 plus H2 plus NaOH. The reaction of Kolbe's electrolytic method is supposed to follow the following path. This is sodium acetate. This will ionize to give acetate ion and sodium ion. Now this acetate ion is negatively charged. That's why it will attract towards positively charged electrode, that is anode. So at anode, this acetate ion loses electron. Each acetate ion loses one electron. So we are taking two acetate ion. So two electrons are lost and this will convert into acetate free radical. Okay, free radical means odd number of electrons on this oxygen. And this acetate free radical further decompose to give carbon dioxide and two methyl free radicals. And then these two methyl free radicals combine to form ethane, CH3. And at cathode, reduction of water is taking place and we will get the hydrogen at cathode. Okay. Methane cannot be prepared by this method. Why? Through this method, the alkane is formed by the combination of two alkyl free radicals. Okay. Just see, in this case, this ethane is formed by the combination of these two alkyl, that is two methyl free radicals. Therefore, it would contain at least 2 carbon atoms. यानी कि जो एल्केन बन रहा है उसमें कम से कम भी 2 कार्बन एटम होने चाहिए. But as we know, methane has only 1 carbon atom, so it cannot be prepared through this method. Okay, thank you. Subscribe my channel to get the next video from this chapter.